Welcome, beautiful peoples in dark core. The Kepler telescope was built for one purpose, to look at a certain patch in the Milky Way in search of exoplanets. The exoplanet hunter observed over hundreds of thousands of stars and discovered thousands of exoplanets during its lifetime. Launched in 2009 as part of NASA's Discovery program aboard a Delta II rocket, Kepler's job was to constantly scan a fixed patch of sky within our Milky Way galaxy to find planetary systems. At the time of its launch, it had the largest primary mirror ever sent into space and a 96-megapixel camera to process the light. Astronomers were interested in discovering how many stars and planets orbiting around them, and how many of these extrasolar planets, or exoplanets, had conditions suitable for life to develop. In its 9 years in space, Kepler observed 530,536 stars and confirmed the existence of 2,662 new exoplanets. These exoplanets are unlike anything we've seen in our solar system. Most are significantly bigger than Earth and orbit so close to their stars that they complete one revolution every few days. Some have star-facing sides with temperatures hot enough to melt iron and hemispheres covered with oceans of molten rock. Others, the size of Jupiter, orbit not one but two stars. Standing on one of these planets, you would witness a binary sunset. Kepler's most significant legacy is that it successfully found Earth-sized worlds orbiting at safe distances from their host stars within the habitable, or Goldilocks, zone, where temperatures are warm enough for liquid water to exist but not so cold that it would freeze completely. While being in this zone doesn't guarantee the existence of life, the presence of water is foundational to life as we know it. One such exoplanet discovered by Kepler that recently generated excitement is K2-18b. In September 2019, two scientific teams independently announced signs of liquid water in the planet's atmosphere. Located 124 light-years from Earth, K2-18b is about 8 times the mass of Earth and 3 times as big. It orbits a main sequence red dwarf star, K2-18. Red dwarfs are the smallest, coolest, and most common stars in the Milky Way. Kepler's data suggests that 6% of red dwarfs have Earth-sized planets in their habitable zones, at least in our cosmic neighborhood. Finding water on one such planet is a landmark discovery in the search for potentially habitable alien worlds. K2-18b is also the first planet with water among all the Kepler-discovered exoplanets in habitable zones. Kepler first discovered it in 2015, and its composition has since been studied using other telescopes like Spitzer and Hubble. Kepler mainly used a transit method for detecting exoplanets, which involves observing the dimming of a star's light when a planet passes in front of it. The level and duration of the dimming provide information about the planet's size and orbit. Detecting this dimming is extremely difficult. Earth, for instance, would dim the sun's light by only 0.008%. Kepler's sensitive cameras were crucial for detecting such minute changes. Using this method, Kepler discovered another potentially habitable exoplanet in 2014, Kepler 186f. Located 500 light-years away, it may have seasons and a climate similar to Earth's. Research from Georgia Tech University analyzed its spin and axial tilt, suggesting its tilt is stable like Earth's, which implies it may also have regular seasons. Research into Kepler's vast database continues at universities worldwide. In recent years, previously rejected exoplanet candidates, false positives, are being reanalyzed with data from other telescopes. One such planet is Kepler 1649c. In mid-2020, while re-examining old Kepler data and cross-referencing with new data from a transiting exoplanet survey satellite, TESS, astronomers confirmed its existence. Kepler 1649c, 300 light-years from Earth, is very similar in size and estimated temperature to our planet. It is only 1.06 times larger than Earth and receives about 75% of the starlight Earth receives from the Sun. It orbits a red dwarf star and is another example of an Earth-sized planet in the habitable zone. Despite the exciting finds, it's important to note that out of Kepler's 2,662 identified exoplanets, only 16 are located in the Goldilocks zone. Some of these planets are tidally locked with their stars, meaning only one hemisphere faces a star, which is not ideal for life. Others resemble smaller versions of Neptune, with thick hydrogen envelopes surrounding possible water layers. If the hydrogen layer is too thick, the temperature and pressure beneath could be too extreme for life. Furthermore, red dwarf stars, though cooler, are often more active than sun-like stars, exposing their planets to high levels of ultraviolet radiation. As a result, surface temperatures on these worlds can range between -100 and 116 degrees Fahrenheit, -73 to 47 degrees Celsius, making them colder than Antarctica or hotter than Earth's hottest deserts. We currently lack the technology to fully analyze the atmospheres and compositions of these alien worlds, but based on Kepler's statistical observations, astronomers now estimate that 1 in 5 sun-like stars have Earth-sized planets with potentially habitable surface temperatures. Given that about 20% of stars in our galaxy are sun-like, that translates to several billion potentially habitable Earth-like planets in the Milky Way alone. While Kepler primarily sought potentially habitable planets, the majority of its discoveries were strange and non-habitable but fascinating nonetheless. These include gas giants, planets mostly made of hydrogen and helium with small rocky cores, also known as hot Jupiters. These orbit extremely close to their stars and appear frequently in Kepler's data. One notable example is KOI 5AB. First flagged as a potential planet in 2009, it was the second planet ever found by Kepler. It initially slipped through the cracks due to the overwhelming amount of data and because KOI 5 had a companion star, complicating analysis. By 2014, scientists determined the KOI 5 system contains 3 stars, making it unclear whether KOI 5AB truly existed. But thanks to tests, scientists later confirmed its existence. Finding stable planetary orbits in multi-star systems is rare, and KOI 5AB's discovery adds to our understanding of planetary formation. Other types of exoplanets identified by Kepler include superheroes, planets more massive than Earth but lighter than Neptune or Uranus, made of rock, gas, or both, lava planets, super-dense, larger-than-Earth worlds in close orbits, some likely the remnants of evaporated hot Jupiters, and Trojan planets, planets found in unusual orbits, sometimes accompanying larger planets, though none have been definitively confirmed yet. Kepler was finally retired on October 30th, 2018, after running out of fuel. The telescope was deactivated with a good night command from Mission Control. Coincidentally, its retirement fell on the 338th anniversary of the death of its namesake, Johannes Kepler. Though no longer operational, Kepler's discoveries predict a future where new and advanced telescopes, both on Earth and in space, will allow astronomers to more deeply study its findings. One such telescope, the James Webb Space Telescope, was set to launch in 2021 and aimed to examine some of Kepler's most intriguing discoveries, bringing us closer to answering the age-old question, are we alone in the universe? What do you think? Will astronomers uncover more strange worlds hidden in Kepler's data? Let us know in the comments below. Thank you for watching Dark Core.